When it comes to the instantaneous change of a function, our goal is to describe how a function is changing. The difference between instantaneous change and average change is that we want to describe the change using only a single point rather than between 2 points. This can be used for things like the instantaneous speed of a rocket a few minutes after launch, or possibly the instantaneous rate of change of a population. One problem we run into is that when we normally describe something like the change of a function, we usually need 2 points to do it. This is so we can record both the change in the y direction and the x direction. If we are at a single point, then it doesn't seem like we are changing in either direction. To see this, you might attempt to use our change formula for a single point. This, unfortunately, would give you 0 divided by 0, which isn't really useful for describing change. Fortunately, there is a way we can find the change at a single point, and the secret is in using the average rate, but in a very clever way. Let's see how this is done. To approximate the change at a single point, we begin by choosing a point along with one other point. This gives us 2 points. Using these 2 points, we find the value of the average rate of change between them. Now, rather than stopping there, we instead start moving the second point closer and closer. Each time we do this, we can record the new value for the average rate between them. Our hope is that as we find these new values, they will begin to get closer and possibly settle on some specific value. This is what we will call our limiting value, and it works great as an approximation to the instantaneous change of a function. Let's take a look at a simple example to see this process in action. Here we have a function, and I want to know the instantaneous rate of change at this point here. I'll choose it along with one other point. Now, I can measure the average rate of change between these 2 points using my average rate formula, and when I do, I get a value of 1. Now let's move that second point a bit closer. If I measure the average rate now, I get a value of 1.5. Let's move it closer again. This time the value is 1.8. As we continue to move the second point, we are getting different values for the rate of change. Even though they are changing, they seem to be getting closer to a limiting value. In fact, it appears they are getting close to the number 2. Let's move them closer still to see if this is the case. After moving them really close together, our value for the average rate is now 1.99, and that's really close to 2. And it's even more evidence that our limiting value is indeed 2. Since we are looking at the average rate and moving the point closer, 2 can be considered an approximation for the instantaneous rate of change of our function. In other words, it gives us a great way to describe how the function is changing at a single point, which is exactly what we want. Unfortunately, we can only call it an approximation. This is because we don't have any way of precisely saying how close to the value of 2 we are getting. Maybe the true value it's approaching is 2.015. Or it might even be approaching 1.993. We can move these points closer together to gather more evidence, but it'd be much better if we had an exact way of knowing what value this rate was approaching, a method for finding the limiting value exactly. Fortunately, calculus has an answer for this issue, and it's one of the first major tools we'll need for many future problems. This tool is known as the limit, and its job is to help us describe what value a function is approaching exactly. We'll save this for the next lecture. For now, it's good to recognize that even without the limit, we can still get a very good idea how the function is changing at a single point. We simply use our average rate of change and then move our points closer and closer together so we can find that limiting value. Thanks for watching. Hey, did you enjoy this video? Don't forget to like it and then subscribe to my channel. If you want to know more about approximating the instantaneous rate of change, you can watch a few examples here. You can also move on to my next lecture where I talk about one of the most powerful tools of calculus, the limit. For some of my other videos, don't forget to visit my website, mysecretmathtutor.com. Thanks again for watching.